अरे वाह! जब जब बोले मीटिंग में ये
Hello everyone, we'll be starting the session very soon. Hello everyone, we'll be beginning the session within 2 minutes. Hello everyone, good morning and dear authors
Dear
and
authors and
invited guests, welcome to the technical session 8A. Myself Anshika Jain and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 8th World Conference on Smart Tents and Systems, Security and Sustainability World S4 2024, London, UK. The 8th edition of the conference is being organized in the hybrid mode. The physical event was organized on 23rd July in London, UK, and the virtual event is being held through Zoom from 24th to 26th July 2024. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started, I would like to introduce you for the chair of the session, Dr. Avizal Abdul Kader. Sir is a senior lecturer, University of Islam Rao, Indonesia. He is currently an associate professor in the Informatics Faculty of Engineering, Islamic University, Indonesia. He is a senior member of IEEE and a member of ACM. His research interests are in software quality models and architectures, software measurements, information systems, software engineering, machine learning, etc. Welcome to the session, sir. Would you like to share a quick opening remark with us?
yes, thank you, Asika. Welcome to our Edwards conference, and again, thank you for the committee to inviting me as a session chair for this morning session. Thank you, Asika.
Thank you so much, sir, for joining in. I would also like to introduce you to our session chair, Dr. Monica Rathod, Associate Professor, International Schools of Informatics and Management, Jaipur, India. Ma'am is currently associated with IIIM as Associate Professor. She has over 15 years of MCA teaching experience. She's a research supervisor at Rajasthan Technical University, Kota. More than 20 research papers have been published in the reputed journals. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
Thank you so much for inviting me, and I'm looking forward for the quality research papers. All the best to everyone, all the presenters. Thank you.
So we will be beginning with the presentations. First up, we have Karar to present his paper titled Applying of Green Material Flow, Costing Advantages Technique for Sustainable Competitive Advantage. Are you there, sir? Are you there, sir? So we'll be moving on to the next paper. We have Ali to present his paper titled Detecting Frame Detection Forgery in Cards dashcam videos, a deep learning approach. Are you there, sir?
Anshika, I'm here.
Yeah, you may
Do you
start with
have
the
my-
presentation.
Sure. Do you have my screen?
Yes, sir. We can see your screen. You may start now.
Thank you very much, Ms. Anshika. This is Ali Rahman Shinwari. I'm from Afghanistan, and I'm doing my PhD from University of Technology, Malaysia. My supervisor, Dr. Oswa bin Khairuddin, and my co-supervisor is Mr. Dr. Fadli bin Hanif. So, as mentioned, the title of the paper is Detecting Frame Deletion Forgery in Car Dashcam Videos, a Deep Learning Approach. So the outline is as following. First of all, I will introduce the videos and the video tampering. Then I will talk about the application of video tampering detection techniques in video frame per seconds in frame types, then the methodology and overall process, the data sets, training and validation loss, and training and validation accuracy, model accuracy on unseen data, and conclusion in future work. Am I audible? I'm sorry. Hello? Anshika.
Yes, sir. We can hear you. You may start.
Perfect. Thank you very much. So what is video? As you all know, video is the collection of images or frames in the time domain. So when we talk about the tampering of videos, so the tampering can be of three types. The very first type of tampering is the spatial tampering. If from a single frame or image, we delete or insert something in that specific frame, we call it spatial tampering. And then we have frame or temporal tampering. As a video is the collection of images in the time domain. So if we delete or insert or duplicate a frame in a video, so in that case, we call it the temporal tampering. In spatial temporal, tampering, when we delete an object from a specific frame, and also we delete or insert or duplicate a specific frame from the range of frames, so we call it spatial temporal tampering. Application of video tampering. So video can be tempered. Like most people are tampering video, but their intention is not to harm people with that. But in some cases, a video can be tempered to, let's say, deframe a personality or a range of propaganda, or for example, to represent a video in courts, or for example, it can be used. It can be used in the insurance, car insurance companies. Yeah. So these are the various applications. When we talk about the videos, so we have frame per second. So in each video, for example, a video, let's say we have a 3-second video, yeah? So in each second of that video, we have 24 frames or 24 consecutive images. And each image is changing after 41 milliseconds, which is quite fast. So the naked eyes of human being cannot catch those frames. Let's say if we delete 3 or 4 frames from 1 second video, so we cannot track that with the naked eyes. So for that reason, we have to have some techniques in order to detect if the video is tempered or not, if the video is forged or not. So the video frame types, when we talk about the videos, so after the compression, video will have the frame types. And those frame types can be I-frame, means intra-frame, B-frame, bidirectional, and P-frames, predictive frames. Yeah. So these frame types are GOPs. We call them GOPs, group of pictures. They follow a specific sequence after the compression. And we use these specific sequences in order to know that either the video is original or it has been forged or tempered. So if you see this image, we have I frames, then we have 2 B frames, and then we have P frame. of the video. So in the next image, we have a sequence of the frames, I frame, then we have 2B frame, then P frame, then 2B frame, then again P frame, then we have 2B frame, then again P frame. So the frames, like let's say, for example, as I said, we have 24 frames in a second. In those frames, they follow a specific sequence. And it really depends upon the encoder or the compression algorithm. So if it's encoded with the AVC, it will definitely follow such sequence, yeah. But if it's compressed with H.265, so sometimes that the H.265 it follows the adaptive sequence of the group of pictures. So in this one, I use this feature. That's why I'm explaining this more. I use this feature. I feed my model with this group of pictures for the training and the validation purposes. So the model is trained with the group of pictures or these sequences. So if we see, it follows a specific sequence. And suppose if we delete 2 or 3 frames, let's say we deleted these B, P, and B frame. So the I frame that is in the 12th location, it will come into the left, and it will be placed in a left side of the sequence. So the sequence will be disturbed, and it will not be same as the original sequence after deleting the frames, let's say 3 or 5 frames. So the next, what we have done here, the first thing was to collect the data. We haven't designed our own data set. We use the open data sets. And after I downloaded the open data sets, then we deleted 11 frames from each video. So each video was 4 seconds, and each second we had 29 frames. So we deleted 11 frames. Then we have performed some data pre-processing in feature extraction. So the feature extraction is to extract these frame types, I, B, and P. We extracted them, and then we build the model, and then we train the model with the feature that we extracted, and then we evaluated that model. So the methodology was as follows. We had input video, and if you see here, if it's visible, we had input videos, and followed by these frame types, which is I, B, and P. And then we had an embedding layer. So the embedding layer is used to create the vocabularies of the token, and followed by the LSTM, the long short-term memory neural networks. And then we use the pool. And since it's classification problems, then we use the binary classification problem. We use the dense layer in order to classify video either that is original or forged. Then the data set, as I already talked about that, in the data set, we had 4,214 videos, and we used 20% of them for the evaluation, and which was 842 videos. And we use 80%, which was 3,372 videos. We use them for the training and validation. And this training and validation dataset was further subdivided into 20 and 80%. 80% was used for the validation, and 20% was used, 80% was used for training, and 20% was used for validation purposes. And this was total video, 4,214. It was like half of them were original videos, and half of them were the tempered or forged videos, from which we have deleted the frames. After the training, we found that the training loss was observed to be 0.057, and the validation loss was observed to be 0.008. And if you see, there are some sudden changes in some sudden hypes because we merged 2 different data sets. And so as the epochs goes on, the training loss and validation loss is decreasing. The training and validation accuracy, the training accuracy was 98.6%, and the validation accuracy was 98.3%, as shown in this figure. Again, as the epochs is going further, I mean, to the right, we can see that the accuracy is improving. Model accuracy on unseen data. On the unseen data, we calculated the recall rate, we calculated the precision rate, and F1 score. All three were calculated. On the evaluation data, the model produced precision rate of 98.5. It was on the unseen data. Yeah, it was on the evaluation set, the one that I showed you before. And the recall rate was 96.9, and the F1 score was 97.7%. Conclusion: this was this model. The model was trained with the data that was compressed with H.264 and AVC codecs, and the GOP structure was as the videos are from the car dash cam. So the GOP structure in the background is moving. It was not a still background like the CCTV cameras. It was a moving background, and so these the same algorithm can be used with the H.265 and HEVC compression, and it can be run with the videos with the still background. I mean the static background or the different bit rates. Thank you, Anishka. Any question?
Thank you so much, sir, for your presentation. Ma'am and sir, do you have any questions?
Yes, thank you, Ali Rahman, for the presentation. Okay, I have one concern. How about the frame is deleted or losses more than one frame? Just now, with slide, I think the slide number 6.
This is the slide number 6 or 7. This one.
Yeah. Number 7. If the
Yes.
let's say I is deleted or BPB deleted, then you move to the a bit forward. So how about the quality? Of course, the lesser is the frame will impact the quality of the video. How about how much the impact to the quality of the video? Because the smoothest video, because of the frame, is normal something about 200 frame per second. If
Yes.
yeah, so far have you tested if the more frame losses or deleted? Of course, I see in your slide, the second row is the number of frame is reduced. Yeah.
Yeah. So, dear professor, after deleting those 3 frames from the video, definitely the quality of the video will be degraded. In addition to that, the frame cannot be deleted in compressed form. So we have to uncompress the video first. Then we will delete the frames from that video, and it will be recompressed again. So even this process, with this recompression process, while we are compressing video again and again, we will definitely lose some quality. And this algorithm was also checked with the deleting different frames, not only 11 frames. I tested this algorithm when I delete, like, let's say 5 frames or 3 frames or 15 frames from a video, and still it was producing the somehow similar result.
All right. Or maybe another option, we just generate the deleted video based on the machine learning before and after the slot of video. I mean, if you deleted BPB and then before and after the slot, so they got something like clue the image. With the deep learning, you can generate based on the both image. Maybe you can try of this. So something like prediction, because the quite fast in millisecond, yeah, maybe, yeah, machine can try to do the estimation of the prediction of the image on the slot. Thank you, yeah.
Thank you very much. Thank you, Professor, for the nice and kind advice. One more thing that I haven't mentioned with this algorithm, it's quite fast and it requires very less memory because we are working on the frame types. I mean the GUP structure, not the pixels. So I tested many other algorithms with pixels, and even I ran Google Colab, but they were requiring a lot of memory and the computational speed. But I run this algorithm on my simple machine. So it's quite efficient in terms of memory and speed.
All right, okay, thank you. Yeah, sorry, I not on the camera. I don't know. When I on camera, just black out. Just now something failed on my camera. Sorry, also Asika. Okay, go ahead. Thank you.
Thank you, Professor.
So we'll be moving on to the next presentation. Next, we have Azia to present her paper titled American Path Loss Modeling for Urban Area, a case study. Are you there?
Yes, I'm here.
Okay, you may start with your presentation now.
Thank you so much.
We can see your screen, ma'am. You may start.
Good. Thank you. Okay, good morning. Good day to everyone. First of all, I would like to thank you, the organizer of the WS4 conference, for giving me the opportunity to present today. My name is Aisha Ilani Sulaiman and presenter today. My paper ID is about 137. I'm from University Malaysia Pahang Al Sultan Abdullah, UMPSA from Malaysia. My title paper is about empirical path loss modeling for urban area, a case study. So outline for today is about introduction, problem statement, objective, empirical models, methodology, simulation flow, result, and also discussion, conclusion, and also our reference. Introduction first. So what is the LP1? LP1 stands for the low power wide area network, means that as a promising solution for the Internet of Things application. LP1 means that you're using the low power signal. CFOT network is very popular for the LP1 technology. The characteristic of the CFOT, such as the long range, because they can cover more than kilometer, long battery lifetime, because more than battery power, ultra low power, using the minimized power, and low data rate, and also low cost. So this is the CFOT network architecture. For example, we have the end device, go to the base station, and we go to the CFOT cloud and also their application. So the performance of the CFOT, especially for the urban, is very important because they in fact impact of the path loss. So what is the path loss? Path loss means that the decrease of the electronic metric wave power that travel from the transmitter to the receiver. So propagation model is very important for the hour coverage and also optimize our resource. From this propagation model, you can see that the transmitter go to the receiver, the signal strength based on our distance, means that the long distance, we effect the signal strength is low. Next is our problem statement. From problem statement, we have the three modules. Akumura-Hatta module, the limitation by Anusha 2018, Akumura-Hatta model, they have the limited accuracy in urban area. For the course 231 module is upgrade from the Akumura-Hatta, they have the more complex algorithm by Harinda 2018. Meanwhile, for the third generation partnership project 3GPP module is to predict higher pass loss value at the greater distance. Means that this module impact of the urban area. This paper objectives is about to analyze the several propagation modules such as the Okumura Hatta, at recent 3GPP module, course 231 for C4 technology in urban area. Means that this paper just only focus for propagation module for C4 technology in urban area. So this key point for this paper is about LP1s, C4s, pass loss models, and also urban area. So this is the C4s logo. This is the empirical model. We have the 4 easy team propagation model. First is about Okumura Hatta model, that they're using the frequency more than 200 megahertz. Next is about course 231 module. Then this frequency using more than 400 megahertz. F stand for the operation frequency in megahertz. Distance stand for the distance between transmitter and also receiver in kilometer. BH stand for the base station antenna height in the meter. MH stand for the mobile device antenna height in the meter. AMH stand for the train parameter in meter, especially for the urban. And last but not least is the C, stand for the correction factor in decibel, dB. The third module is about at recent module. This module, they have the fixed value A0, A1, A2, and also A3. And also the last module is about 3GPP module. Next is about our methodology. This paper just only focus about C4 technology. C4 is very unique because they allow device to communicate over long distance with low power. And also the propagation module, they have this paper just only focus 4 propagation module. First is Okumura Hatta module. Second is the course 231 module. Second is Harrison module. And also third is about 3GPP module. This paper just only focus for the operating frequency for the 920 megahertz because we just only focus for the Asia area. And also for the base station antenna height, or we call the BH, we select 10 meter and also 50 meter for the minimum and also maximum. For the mobile device antenna height, or we call the MH, we set 10 meter. And last is distance between transmitter and also receiver, or we call the D, we set for the 10 kilometer for the urban. So means that the parameter, the changing parameter just only for the BH. The rest is the fixed value. So this is the isolation of the C4 device at the urban environment. First, number 1, we have the BH at the transmitter. And also we have the mobile device antenna height at the receiver. And between them, we have the frequency and also their distance. Simulation flow. This is about the evolution of different propagation module flow. First, we start our process. Second, we must study about C4 radio parameter first, such as the about frequency, about base station antenna height, about mobile device antenna height, and also their distance. Next, we go to the setup simulation using the MATLAB software. After that, we apply the 4 propagation module, that is Okumura Hatta, course 231 module, Harrison, and also 3GPP module. Next, we can run simulation separately, means that we run for the Okumura Hatta first, then we run for the course 231 second, third Harrison, and also 3GPP. Next, we can try to comply with requirement, means that the result is meet the requirement. If yes, we go to the analysis. If no, we must return back to the application propagation model, means that we need to check back the formula. If yes, we must analysis and compare the result, means that from 4 modules, which one the best for the C4 in the urban. And after that, we end our simulation. And go to the result and also discussion part. From this graph, based on empirical pass loss module at BH equal to 10 meter. From this graph, you can see that we have the 4 propagation module at recent. Actually, for this graph, we have the redundant propagation module, Akumrahata, cos 231, and also at recent. From this propagation module, we can see that cos 231 is similar with the Akumrahata. But for the 3GPP is more better compared 3GPP better compared to Akumrahata because Akumrahata is based on all the data. And for the recent module, you can see that is the optimized compared than Akumrahata and others module. From this graph, you can see that this module demonstrate how signal strength decrease as you wave from the base station. When we comparing with the BH equal to 15 meter, we can see that 10 meter previously is the pass loss is increased, but for the 50 meter, the pass loss is decreased. When we comparing for the recent model, we can see that recent model is perform the best. From this table 2, the average pass loss in urban scenario using 4 propagation module. As you can see that we have the comparing for the BH 10 meter and also BH 50 meter for the 4 propagation module. We can conclude that a recent module is better performance compared than other modules in urban area because at least we have the low power pass loss compared than other. And also the BH, or we call base station antenna height, is very important playing in design our efficient cellular network that directly impact our coverage and also reliability in urban area. So our conclusion, we can see that this paper, we explore the pass loss performance CFOX that we using the empirical pass loss, means the Akumrahata, 3GPP, cos 231, and also at recent. Next, we can see that at recent module outperform compared to the others based on the pass loss result. And also we can say that base station antenna height or BH is very important in design our cellular network that will impact our coverage and also reliability in urban area. Last but not least, in future research, we want to modify the research model for the urban for using the least square algorithm. So this is our reference. That's all for today. Thank you.
Thank you so much, ma'am, for your presentation. Sir and ma'am, do you have any questions?
Yeah, sorry, I have concern.
Share my slide
Aisyah.
back. Okay, yes.
Yeah, I have a result. Sorry, my camera not on. Okay.
Okay.
In your simulation, do you something like create contour, because in urban area so many propagation like building trees, high buildings, the contour of the earth is a hill, something mountains. In just now you are using what software to simulate?
MATLAB, just only MATLAB starting.
Oh,
Yeah.
maybe you can import the geographical or the contour of the earth, the surface, so more accurables. Just now you mean just assume the contour of the earth on the surface is just something like flat. In
Yes.
actual, different area may have different sometime losses because the different city, different sign of the building. Maybe
Yes, correct.
yeah.
Yes, doctor.
how the currently is just the currently you do the MATLAB not import is not involved in the surface of the earth.
Not import.
Oh, no, import, yeah.
Because just only simulation, Doctor.
Yeah, just to do simulation. I mean,
Yes.
next time, because
Uh-huh.
like cellular provider, they have to
Mhm.
do the real, and
Uh-huh.
every year they need to update.
Yeah.
Because every year the building is high, the
Yes,
tree.
correct, Doctor.
All right.
All
Thank
right.
you. Just
Thank you so much.
this my
Thank you so much,
concern. Thank you.
Doctor.
All right. All right.
Thank you so much. So we'll be moving on to the next presentation. Next up, we have Omno Pichemi to present his paper titled Machine Learning Algorithm for Classification of Infant Cognitive Anomaly. Are you there, sir?
Yeah.
You may
just-
start the presentation, sir.
All right, thank you. Yeah, can you see my screen?
Yeah.
All right. Good afternoon, everyone, and much appreciation to the organizer of this conference. I would like to start my presentation on the topic, machine learning algorithm for classification of infant congenital anomaly. So, congenital anomaly is a structural flaws in fetus, which is called CA, and CA can lead to complicated pregnancy and disability later in life if it is not properly detected and being taken care of at the early stage. CA, according to the World Health Organization, it estimates that at least 290,000 deaths that occur worldwide have been led to congenital anomaly, which is about 7% that death that is being caused, right? Congenital abnormality can result from a variety of causes, some of which can be identified, while others cannot be identified or being discovered. The most prevalent and common birth malformation globally are called the spinal bifida, which affects the spinal cord, basically, and ranges from clubfoot, Down syndrome, Polmenic stenosis, Atrocious, and cliff pilots. Limb deformities, congenital heart disorder, neutral tube effects, and Down syndrome have been associated with congenital abnormality. Ultrasound, that is US, is performed in the first trimester for determining the number of fetus and assessment for complications of early pregnancy. The problem statement: spinal bifida affect the central nervous system, the CNS, SP, may make work painful or even impossible if it's not been treated or discovered at the early stage. Inability to identify early spinal bifida and diagnosis can result into a lot of issues. Radiologists are limited by fatigue, speed, and experience to discover that. Limited availability of data to operate at their best operation for deep learning prediction have been associated as the primary causes of spinal bifida. Adaptation of modeling approach, which are based on spurious data findings, such that data could not be verified, are factor that contributes to the problem statement of CA. So basically, the cost of our research, we use 3 different deep learning algorithms, which is the DBN, Deep Belief Network, UNet, and DRN, that is the ResNet. So what we did here was from the stage 1, we got our ultrasound image, which was basically downloaded from Google, and we load that straight into the stage 2, where we have the extraction using the CNN, that's convolutional neural network. And here, stage 2 is all about the process fitting that goes through the cleaning, the replacements of value, scaling, and the SBF. So this is where we perform using different algorithms, as I said earlier. And the excess of trying to use different algorithms is to enable us to know the most and best algorithm that perform well, right, to detect spanner feeder. So from there, we load it down to stage 5, which is more of the hybridization stage, to see the one that is mostly effective when it comes to the filtering of those algorithms. And we have the training stage, right, which is stage 6. And we load it to stage 7, where we have our results and we do the evaluation. So in the course of our results, we use a Jupyter Notebook, right, to run our codes. And this a little bit of the snippets code that we generated. This result shows for the ResNets. We have the receiver operating characteristics and validated result of about TPR, this true positive rate, is about 97%. That is for the ResNet. And the false positive rate result is about 2%, indicates good performance of the model. This appears from the developed ResNet algorithm. Model has more performance compared to the UN and the belief network. So this is the UN algorithms, right? So for the UNet algorithms, we have 96%, and we have accuracy at about 0.91, which was actually shown up there compared to this about 0.94 downward. And this we have is 0.91, 0.93, 0.96, and the true positive rate is less than 2%. And this suggests that the UNet algorithm performed more better compared to the ResNet shown above. Above all, the deep learning, which is the deep belief network algorithms, has about 0.96% compared to all of those 2 different algorithms that we used earlier. And it has about DPL, true positive rate of 98%, and false positive rate of about less than 1%. So at the end of the day, we're able to draw some pictorial graphs to show the relative relationship between the spanner feeder and the normal and the abnormal one. And we could see, as been indicated with the right graph, that the spinal feeder has a very high ratio there compared to the normal spinal feeder that we've got. So the conclusion of the whole research, this research model will assist medical professionals to forecast and manage the causes of spinal bifida. And at the same time, the model will provide several causes of diseases by curbing infant mortality rate if this is being discovered at the early stage of diagnosis. The global causes of this disease or this problem require an early detection as provided in the model. The model can be developed it can be deployed in different hospitals and different research centers to identify this. Thank you.
Thank you so much for your presentation, sir. Sir, do you have any questions or ma'am?
Maybe Monica, maybe?
No, I guess ma'am doesn't have any questions, sir. So we'll be moving on to the next presentation. Next up, we have John to present his paper titled Network Monitoring System for Sniffing Attack Prevention in Wireless Communication Networks Using Secure Socket. Are you there, sir?
Yes, I am, please. Kindly enable me to share screen.
Yes, sir. You may present now.
All right. Can you see my screen, please?
Yes, sir. We can see your screen. You may start.
Okay. Thank you. Good afternoon, everyone, delegates to the conference. My name is Dr. John, and I'll be presenting a paper on network monitoring system for sniffing attack prevention in wireless communication networks using secure sockets. This paper was put together by a team of researchers across different universities in Nigeria, as listed in from number 1 to number 6, basically 2 different universities. Some of us are already online partaking in this conference. So I'll be speaking through this directory. I'll introduce it and then look at a few related works that we have reviewed, and then present the materials and methods. And then we should result in discussion, conclusion, and references. So for our introduction, computer network monitoring systems are crucial for gathering evidence in cases of computer fraud, especially for digital forensics analysis and investigation. So it becomes very useful for gathering evidence of analysis. So what this research does is to introduce a tool which we call sniffing attack prevention tool called SNAP, which utilizes sockets to connect the client node and the server node for scanning open and close ports on a wireless network. The goal is that the tool, when deployed, should be able to detect ports that are open or closed, to block them to prevent sniffing attacks on the network. So we leveraged Python 3, because of its rich library, especially the SCAPI library and other libraries that were used to develop the solution. So the solution was able to detect and then block ports that were seen to be open and could possibly become attack vectors for attackers who get access to the network for any malicious intents. Furthermore, the experimental results of our system, which we call SNAP, demonstrate its ability to scan for various network parameters, and then it was able to detect and then block some IP addresses within 2 minutes, where ports 135 to 139, which are for SMB, were closed, were shut down. There were 3 major papers that were that are actually presented here. A number of them were presented, but we're showing only 3, which are very close to what we did. Tanker 2022 proposed a reverse proxy-based NAT penetration solution, which they called PRODASA, for monitoring ports behind NAT network. Even though this was very good because they were able to perform scanning network using a probe delayed adaptive algorithm. There were 2 major setbacks. One was that there was a need for port to be scanned behind the network, and then there was a need for balance of adaptive changing port scanning method. And then the second work, which we also reviewed, is the work prepared or presented by Kari and Takramati 2021. What they did was to include shadow TDRO, an information flow tracking algorithms, to develop a solution for also detecting ports and closing ports using the IJTAG framework. The challenge with this system was that it does not actually protect the IJTAG from data sniffing assaults, which is one of the problems we saw, but there is a need for us to tackle using our solution. And then the third work was the work by Pavlovic 2021, which what they did was to incorporate an easy-to-use interface for protecting gateway architectures for IoT devices. The emphasis was actually on IoT devices because of the limited resource powers that IoT devices have, and their increase in attack vectors that could be exploited. And the drawback for this system was that it was evaluated for memory utilization and the virus threat was very low. So that made our solution to stand out. So for materials and methods, for the design tool, the SNAP was developed using SCAPI library in Python 3, which I mentioned earlier. But a number of other libraries and tools were incorporated, like the PyFuglets for fancy and other things, to make the tool not just functional, but also to be user-friendly and interactive. And then also for the method, for the detection and prevention of sniffing attacks, the selected libraries worked very well on wireless connection networks and helped to develop the SNAP capable for generating and sensing and blocking open and closed ports. And then for port identification, the open port was identified using socket library, and then PyFuglets and other tools that were used. Now, figure 1 on the left shows the the flow chart for detecting and blocking sniffing attacks, starting from the starting of the process through imputing IP addresses. Actually, 500 IP addresses were imputed from the network that was used to test it through. And then we went through scanning for open ports with the IP presented, the IP addresses presented, and then the scan of the for the sniffing attempts were carried out. And then sniffing attempts were detected when we have the yes, where the tool was able to block the ports. If not, then the scan continued till we completed the process. And then the figure 2 shows the modules for monitoring sniffing attack. Basically 5 major modules from packet traffics for packet monitoring, detecting sniff continue, and then blocking host of sniff detected. So these two diagrams show how we were able to carry on with the development and implement or the testing of the tool. Then for results, the scanning results. The results showed that 500 IP addresses and 200 ports were scanned in 2 minutes, showing the level of latency that our solution, our tool brings. Actually ran fast and showed that ports 135 and 139 were opened, and port 190, but 198 ports were closed before the sniffing attack was detected. And then the action on the result, most of what was done, what was detected after attack detection was spotted. The tool was able to block the ports to prevent attack from taking place on the system. And then finally, a confirmation message was sent, which would actually help the administrator to make a decision as to either allow or disallow the process. And then further on the results, when harmful services are added to a system via malware or social engineering attempts, or even when lawful services are exploited through security flaws, open ports are at risk because the attackers access sensitive data without authorization. We know from experience that attacks actually take place where ports are open, especially those ports that are providing services on critical services on a network, on a system. So this too becomes very useful to make sure that those ports are taken care of to avoid any eventuality. The first functionality of Snap tool was to carry out the functionality of the port scanner. After the port scanning, then the blocking of the port. We also show that the open and close port between 1 to 1,000 on this particular network was to remain for the network used for testing our tool. Now, the figure 3 shows a snippet of the tool for implementation of the open and close ports. And then figure 4 shows the scanning process for open ports and closed ports. Because we use sniping, we decided to make it interactive using the prompt. So where a user could be asked to specify the number of addresses, IP addresses to be scanned, and then one will supply, and then the tool will scan the network to see which of the ports is open or not. And then figure 5 shows the code snippets for detection and prevention of sniffing attacks. Looking at figure 6, the packet sniffing for open ports or closed ports is also shown here. You can see the number of IP addresses with some flags where the tool was able to scan and then show what is actually happening on the network. Then figure 7 shows the result of the detected sniffing attack. It also shows the different IP addresses that are at risk and the ports, and then the different flags, the same flag as it was able to detect. And one of the critical solutions that this our tool brings to board is how to handle false positives and false negatives. Now, we know that false positive may occur when a normal network behavior tool is incorrectly identified as a sniffing attack. So to mitigate this, the Snap tool employs advanced algorithms and heuristics to analyze network traffic patterns more accurately to make sure that false positives are actually minimized as much as possible. And other techniques that were employed to reduce false positives. And then for false negatives, false negatives occur when the tool fails to detect actual sniffing attacks. To address this, the Snap tool employs multiple detection mechanisms heuristics to increase the sensitivity of the system to make sure that there is a reduction in false positives. or the false positive lengths, which is actually critical for an intrusion detection system or intrusion prevention system, or a scanning tool or a sniffing tool. And then the last component of the system is preventing unauthorized access.
Sorry to interrupt you, sir, but you have 2 minutes to conclude your presentation.
Thank you so much. Thank you. So the system or the tool was also developed to make sure that unauthorized access to the network was prevented. So thank you. This solution, this research was actually supported by the African Center of Excellence in Obafemi Awolowo University in collaboration with the Digital Science and Technology France. Thank you for listening. So I wait your response or questions, please.
All right.
So,
Thank you. Yes, Azika. Okay. Thank you, John, for the presentation. I just simple query. Maybe have you compared to other method? Just now you mentioned you present 500 IPs detected in 2 minutes. Use this secure socket monitoring. How about have you compared to other method? Have you tested with other method? Which how the accuracy your technique compared to others?
Okay, by method, I suppose you are referring to other tools. Is that right?
I mean the comparisons, the performance comparison. Now you are a snip at the socket, okay, secure socket. How about the just now the result? You find 500 IPs detected. Have you compare tested to other method, other technique?
Okay, for we have actually, I think I've listed here, I left it. We intend to, this is experimental resolution, which we tested on the network to test, to scan the IP addresses. What we need to do is, first of all, we're going to incorporate machine learning, which is the next phase of this work, machine learning algorithms to it, and then compare with existing tools to see the difference in the evaluation performance. Does that answer your question?
No, I mean to check the how good the performance of your snipping monitoring based on the port, the socket, the secure socket. Maybe you can test like others method and other maybe another part of the you test how the performance, how the snipping attack at the wireless monitoring or it's okay.
Okay, that is
yeah.
okay. All right.
Thank you, Asika.
thank you.
Okay. Yeah.
We'll be moving on to the next presentation. Next up, we have Barot to present his paper titled Wireless Automated Exhibition System, Convenient Mobility at Low Cost. Are you there, sir? Are you there, sir? So we cannot hear you.
Can you see?
Yes, sir, we can see you.
Can you see the presentation?
No, sir, we can see the students there. Can you please share your screen for the presentation, sir?
I think you just move the camera to your projector.
Yeah, please
You
move
drop
your camera towards
presentation.
your projector.
Yeah.
Can you see?
Yes, sir, we can see. You may start now, sir.
Yes. Okay.
Good afternoon, everybody. Today, I would like to present wireless automated exhibition system, convenient mobility at low cost. I am Tabo. I am a student from Faculty of Engineering and Industrial Technology, major Electrical Engineering, Phetchaburi Ratchapat University, Thailand.
My name is Pimukon Kamngan from the Udom Siksa Pathanakan Sunnarpum School.
My name is Lyric Kapankor. I am from Phetchaburi Ratchapat University Demonstration School.
Agenda. First, introduction. Second, methodology. Third, result. Fourth, conclusion. Introduction. Exhibition system. The existing system, manual work, need human. This research, automatic work, don't need human.
Our research methodology involved three key phases. First, design, then implementation, testing, and the last but not least, result. This method is way to guarantee the efficiency and viability of the system in an exhibition environment. The system architectures involve configuring visitor setting, wireless sensor detect visitor entering and exit the exhibition areas. Once the predetermined number of visitors is reached, the system will automatically start or stop exhibition display. On the other hand, if some people leave during the presentations, we can set a setting to stop the presentation. The first basic conceptual and architectural design of the system whereby incorporate elements such as wireless sensor, central processing unit, display interfaces, and the design of the software for processing and controlling the data. In addition, IR sensors send the data to ESP32 and ESP32 send the data to the central system. The software will go involve starting the program, setting the desired number of attendees and initializing cultures. The system continuously monitor attendees' arrival and leave that they are updating the count accordingly. The implementation phase involves setting up the infrared sensor for detecting individual entering and exit the exhibition room. The system consists of three main components. These include the infrared sensor, ESP32 transmitter board, and ESP32 receiver board. The receiver board outputs signal to LCD screen and the Leonardo board, which in turn controls of notebook to pause video whenever required.
Result. The picture shows the range operation between sensor and human. From table 1, we show the result of 20 tests conducted with sensor placed at distances of 10 to 17 cm. Can be detection 100%, however, at 18 cm, detection are not possible. The picture shows the range operation between sensor and central. From table 2, which present the result of 20 tests, this is clear that wireless signal can be successfully over a distance of 10 to 90 meters with a 100% success rate. This is the video of the incoming people count. You can see the last person in back shirt. The exhibition will play automatically. 3. The intent system test found that out of 20 tests, the system working at 100%. And here's a video of the departure call. You can see that when the last person leaves system stop paying. Function 4. This is test of its exit system is well found that after testing 20 times, the system working 100% as well. This system can operate in the crowded operated area testing it 20 times. With him a 15-meter range is 100% success rate. First image test is when two people walk past at the same time, the sensor will count as one. Next picture, if two people walk together at the close distances of distance, the sensor will measure one. And the last picture, if someone walk out of in the entrance at the same time as someone walk in the sensor will count at 3.
Conclusion. This research have benefit as the following. First, the wireless with a detection rate of 100%. Second, the extended counting 100%. Third, the automatic exhibition works 100%. This setting distance between sensor and control allow 20 meters 10 times. The end. Thank you very much. Do you have any questions?
Thank you so much for your presentation. Sir, do you have any questions?
Yes, just a simple query. Based on your video just now, the performance, how the mitigation to the noise? I mean, of course, in the conference on the venue, even in the classroom, we consist of several projector. Just now I see in the classroom how to mitigate the projector to another classroom. Of course, you have ID, every projector, the ID. So far, how the result, the performance of your testing? Is it can interference to other projector?
Yes.
Do you understand what I mean? Just now you saw the testing at the one of the classroom. I guess at the next room have another projector. How is it? Is it can avoid the? I mean, I see the student coming in, the projector on, and when the lab out to the classroom and the projector is off, suddenly, how the interference if someone have the Wi-Fi access or the noise, I mean, of course, in the public area, there is many Wi-Fi hotspot, someone telling and other. How to avoid this interference to this to your system?
Currently, I'm testing for the crowded people. The wireless can work 100%, allow 20 Mbps, and this is a proof that our ESP32 is very good for the Wi-Fi at this area, and it did not have the noise from the crowded people.
Okay, I see. Yeah. Next on, we need to think because someone hacked maybe on your presentation in the conference or in the classroom. Maybe someone hack is not your source of the video or the materials, maybe someone as their material or video. It may happen for the next on. Yeah. Thank you for the presentation.
Okay,
Thank you,
thank you.
Ansika.
Thank you so much. Do we have Karar to present his paper? No. So, I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being the part of this international conference. I hope the session was informative enough, and on the behalf of the whole team, thank you for your support during this 8th version and all the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025 as well. All the presenters would be getting the digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the printer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2024. I would also sincerely like to thank our session chair, Dr. Avizul Abdul Kader, for chairing this session. Thank you so much, sir. This is a token of appreciation on the behalf of the whole team of World S4 2024. Would you like to share a quick closing remark with us?
Yes, thank you, Ansika. Yes, thank you to the committee for the World's 8 Worlds 2024. As usual, I am the session chair, and thank you for the presenter. You have the best good paper presented. Keep continue for the research. Yes, thank you, Ansika.
Thank you so much, sir, for your valuable presence. I would also like to thank our session chair, Professor Monica Rathod, for chairing this session. Ma'am, do you have any closing remarks for us? Okay, I guess there might be some technical issue. So I would request everyone to please switch on their cameras for a quick snapshot. Yeah. Thank you so much, everyone, for your valuable presence. It was a great session. Thank you.
Thank you. Bye.
Thank you.